that because I know we have, there we go.
Yep.
So welcome everyone. First of all, I apologize that my video is not working tonight. I could not get it to work, but I am Lynn Seaman and I am the membership person for the Horned Lizard Conservation Society. I'm going to be the moderator and get things started tonight. Let me introduce our wonderful guest. We have Nick Cairns, an ecologist based in southwestern Saskatchewan. He has worked on a variety of species and projects, including mitigation strategies for turtle bycatch in inland fisheries and phylogenomics of the spring peeper. His obsession with horned lizards started in childhood, but was really kindled when he volunteered at the Southwest Research Station and was introduced to the beast firsthand by Wade Sherbrooke in 2003. After that, he moved to the Canadian Prairie and started watching greater shorthorn lizards in Grasslands National Park. He has conducted horned lizard surveys there since 2013. While he has moved back and forth from graduate school, he is still based there with his partner and 2 children who regularly join him on weekly lizard walks. He received the Laurie Papenbrink Award for HLCS in 2021 and has used the funding to conduct research into horned lizard overwintering. So Nick Cairns is one of our speakers, and also we have Larry Powell, an evolutionary biologist, ecologist associated with the University of Calgary. His Master of Science research was on the ecology of the greater shorthorn lizard in southeastern Alberta, and he has since conducted research on distribution and abundance and on movements, home range, and overwintering in the species. This fascination with horned lizard has also resulted in a doctoral project on the evolution of head shape in Phrynosoma, a topic that he is currently exploring in greater depth. Other field research has been on the ecology of the long-toed salamanders in the Front Range and the movement patterns of the prairie rattlesnakes in southeastern Alberta. In addition, he has been involved in research on reptile, dinosaur, and mammal anatomy, mainly from a quantitative perspective. So we want to give you a big welcome tonight, and we're glad that you're joining us. Just a couple of reminders for the HLCS that if you want to order anything from our store, you need to get those orders into for a period of time over the Christmas holidays. And we also want to remind people that our grants are open. The applications for grants this year are open and available on our website. We can send you a link for that or give you more information of that later. During the presentation today, if you have any questions, please feel free to put them in the chat. And at the end of the presentation from our wonderful speakers tonight, then they will answer those questions at the end. And I'm going to turn it over to you. Nick, I think you're going to go ahead and start, and I'll let you go ahead. Thank you.
Thanks so much, Lynn. And thank you, Lynn and Mason, for setting this all up. And I also thank you at the end, but thank you very much also for making those grants available, because that paid for a significant portion of what I'm going to be talking about today. So I really appreciate it. Sorry, I just got to share my screen here. All right. So as Lynn was so kind to report, my name is Nick Cairns. I live in Val-Marie, Saskatchewan, and I'm really honored to be joining Dr. Larry Powell to be talking about the state of horned lizards in Canada from our respective positions and provinces. We're going to chat a little bit about natural history and ecology in the context primarily of northern populations, and we're going to touch on some issues of conservation and maybe some specific threats. So historically, there were 2 species of horned lizards found in Canada. There is currently only one. Phrynosoma douglasii, or the pygmy short-horned lizard, used to be found in central British Columbia, which is the westernmost province of Canada. Unfortunately, the last official report was in 1957 and has since been declared officially extirpated, i.e. extinct in Canada, although it is found relatively close to the border in Washington state. So hope springs eternal, and I think almost every herpetologist in Canada has tried their luck at one or more sites that historically had them, and we've all more or less come up empty-handed, unfortunately. Phrynosoma hernandezi, or the greater short-horned lizard, is doing a bit better than extirpated, and it's the same species generally that you would see in the Chizos Mountains in Texas or across much of the Sierra Madres in Mexico and in Arizona. And across many of the sort of Great Plains states in the US along the Rocky Mountains, so on that western side of the Great Plains. It reaches its northern range limits here in Saskatchewan and Alberta. It actually goes a bit further north in Alberta, but Larry will talk about that in a little bit. So the first thing I want to talk about a little bit is, I'm going to, I messed my notes up here. The first thing I'm going to talk about is a little bit of the conservation status of this species, because we did cover the status as extirpated for douglasii. There are unfortunately 2 components that you need to understand about Canadian conservation statuses, and that is that there are 2 statuses for every species. The first being the one presented by the Committee on the Status of Endangered Wildlife in Canada, also called COSEWIC, and the second being the SARA status, or the Species at Risk Act status. This is the one that actually provides them with legal protections. So COSEWIC is an arm's length organization that advises the government about the risks to species only. It doesn't incorporate anything about economic impacts. And so under COSEWIC, it's not really provided any actual protections, but it's the one that's the most sort of broad scale in terms of its understanding of how the species will be affected without any political implications or anything like that. It is apolitical. And this one advises the government. Now, this species is an interesting case because under SARA, so the one that it actually has legal protected status, it's considered endangered, and so therefore has habitat protections, at least on federal land. However, it was recently relisted or downlisted under COSEWIC, which means that at some point SARA will likely follow suit and downlist it. Now, I've seen a few cries of success, this seen as a success. Unfortunately, there are no real improvements of the species status on the ground. This redesignation was largely a representative of the fact that there was a change in assessment criteria for COSEWIC under what we can describe as fragmented. This was done to match the criteria presented by the IUCN. And so it makes sense to do it so that everyone's working from the same field, but unfortunately it's led to the downlisting of a species that might still require some additional protections, including habitat protections. So most of the threats still remain, and unfortunately some of them we understand very poorly, and so we're not able to really assess this species quite often because a lot of the threats, apart from just building a road through their habitat, are very difficult to understand how this species deals with these threats, largely because there's never very many horned lizards in one spot. So it's very hard to get any significant answer to do with this species. That said, there's still some really interesting threats that we're working on understanding. Some of those include things like habitat modification and oil and gas drilling and the associated pads and roads that come with this. These are relatively well understood, although protections are still sometimes difficult to push through on those things. And other things like shifts in climate and precipitation patterns are a little more difficult to understand how they will affect species at their northern range limits. And so we're working on answering some of the ways that these species react to precipitation patterns and changes in temperature and see how that they'll do in potential modeled future scenarios. Additionally, there's things like subsidized predation, changes in novel predators or mesopredators coming into the environment due to trophic release or human subsidization that can have some major effects on these species. So I just wanted to point out where Saskatchewan and Alberta are here. So you can see Montana here. This is Montana here. This is Saskatchewan here to the right on the sort of the eastern side of Montana, and Alberta is on the western side here. So let's talk a little bit about Saskatchewan. I love Saskatchewan. I live in Saskatchewan, and I would like to continue living in Saskatchewan as long as I possibly can. It's an interesting province because it's often thought of, at least in Canada, as a very flat mixed grass prairie with very little topography and relatively good growing conditions. Unfortunately, for those people that choose to farm in the area that I live in, that's not the case. We have a lot of topography, it's very dry, and we have a lot of really specialized plants and animals that live here because of those conditions. So over much of their range, Phrynosoma hernandezi is an upland species. Those of you in Texas probably would only see it in mountains. The first one I ever saw was in mountains in Arizona. They're often associated with quite high Madrean woodlands and pine woodlands, but that's not the case here. Here, across much of the Canadian prairie where they do occur, they're typically associated with sort of badlands type habitat, associated along with major river valleys. They tend to use the eroded slopes and coulees that are dominated by relatively short forbs and sparse grasses. And now, despite the image that I've painted in your heads, they're not really living in a really simplistic environment. They like structure. They prefer highly structured habitat. And though it's relatively short, they like a diversity of things to get underneath because there can be so much diversity in temperature in a very, very small area. And so they like to have a diversity of different plant covers, some with better canopies, some with lesser canopies. They like to have big rocks. And they can find this in relatively small areas. And Larry's going to talk more about that in a little bit. In this area, they're almost always associated with Bearpaw Shale. And this is a Cretaceous marine deposit, and it flakes away and it forms these little sort of, 5 millimeter to 2 millimeter little flakes of clay. And although it's not as easy to burrow in as sand, it's a lot easier to burrow in than just straight clayey soil, which is what the rest of the soil in the area represents. And so this allows them to get underground a little bit during inclement weather, during the summer, as well as in the winter when they burrow for brumation. In Saskatchewan, they're located primarily within the confines of Grasslands National Park. There are some on private land, but for the most part, they're within the park's boundaries. The vast majority of recent records come from the West Block. That's this area here. This is the French River. This is where I live. That's with the exception of a few that have been found in the East Block. Almost no lizards have been found in the East Block, with the exception in the last sort of 15, 20 years, despite search effort that's been not, it's been reasonable search effort. But we just can't find lizards. We did find a population as part of the Royal Sask Museum's surveys in 2013. We found a new population that was a little further north in the East Block than they've historically been found. But it represents a tiny population, maybe 6 or 7 adult females. So it's not really a sustainable population long term. The lack of observations is worrying, as these surveyors that were surveying most of the East Block were checking historical records. These were areas that other researchers like Larry had searched and found lizards in the past. Larry, I believe you did search the East Block, right? Yeah, in the 98 paper.
Sorry. Yeah, I did. Most of my finds were down in the lower reaches of Horse Creek.
Yeah, but we can't find them there anymore. So this is what I mean. It's really unnerving because some of these records are well known, but we can't seem to find them there anymore. So despite being in a protected area, these populations do not appear to be free of threats. So with that, I'm going to leave Saskatchewan, just putting that threat in everyone's mind. And we're going to move to Alberta, and Larry's going to fill us in on how they're doing in Alberta.
Oh, it's my turn, is it? I think you have to stop. You have to stop sharing.
I will stop share.
Okay, give me a moment here, folks, till I get to my slides. And there they are. I've lost my cursor. Oh, come on. Sorry, folks, this is an old cranky computer.
I should mention, actually, while you're looking there, Larry, that I am a member of the Reptile and Amphibian Specialist Group for Coast CWIC. And so although I mentioned that this is a change in rules, it's a really well-functioning body, and it's nice to have a conservation group that's not political in any way. But yeah, so we still have rules, so that's where that range in rules game. Any luck, Larry?
Can you tell me what you're seeing?
Oh, you started sharing your screen now.
Ah, Bonzer. Okay. As I said, this is not a very responsive machine. I'm sorry about this, folks. Can't afford a new one right now. And okay, yeah, good. My connection's unstable. Better and better. Okay, just so you can everybody see that? Can somebody let me know?
It's working.
Yeah, I can see it, Larry.
Okay, just so you can see how magnificent shorthorn lizards are, there's a big female from, oh dear, where was she? Comrie Breaks, down near the border. And there's, hang on. Oops, whoa, there's another couple of views. Just if you're unfamiliar with the species, this is a big one. And she was about maybe 70 millimeters snout bend length. This is, stole this from Magdalene Lung. The range in Alberta, there's Alberta, okay, there's the Montana border. And I'm up here in Calgary, and this is the southeastern corner of the province, which is where they're restricted to. Now they go all the way up to about 50 degrees north. The border is the 49th parallel. And the distribution seems to be in patches. We've got, we can never say these are contiguous populations. These pink areas here just indicate where you have a very high likelihood of finding a population. But of course, their distribution is spotty. As Nick said, they're hard to find. You can never be quite sure if you're not seeing them because they're not there, or you're just having a bad day. But we can group these populations into 4 clusters. Well, these 2 clusters are sort of similar in terms of habitat, but they're found along the Milk River. And this is actually draining into the Missouri. It's one of the very small areas of Canada that's in the Missouri Basin. South Saskatchewan here goes up to Hudson's Bay. So we've got lizards that are on their way up to, if they kept on colonizing north, on their way up to the Arctic. Anyway, down here in Milk River, there's typical habitat there. It's coulee edge. They like that sort of thing. They'll be found along these bare areas. Of course, they've got interspersed with those, they've got areas of thick grass, which they make fairly heavy weather of. And this is worth noting because we can actually see human habitation here. Most places you find shorthorn lizards in Alberta, you don't. But this is the Gilchrist Ranch or Deer Creek Ranch, and they've been there for about a century. And the horned lizards are living quite close to them, quite happily. This area here is very much like the area Nick was talking about. This is what the Bearpaw Shale Hat Badlands in South Saskatchewan are like. We have them in southern Alberta too. That's all these populations in here in the Manyberries Hills, and that's Manyberries, that's a town. And you can see the micro topography here. It actually is quite topographically varied at a very small scale. And as Nick said, that provides a very varied habitat for them for thermoregulation and feeding areas and so on and so forth. And then here and here along the South Saskatchewan, along Chin Coulee and 40 Mile Coulee, oops, yeah, I did it again. That's the sort of habitat you find them in there. That's along the South Saskatchewan. That's right about here. This is one of my study sites. And you can see they're on these slopes. You go very far back from the slopes and they're not there. They like the slopes. And you can imagine doing field work in here really builds up the ankles. And this is a southern exposure, although not all the populations along here have southern exposures. They seem to like it. Now up here, north of Medicine Hat, that's another town. Towns in this area have funny names. There's a place down here called Seven Persons. They're translations of Blackfoot names. Anyway, north of Medicine Hat, about 30 kilometers north, maybe a little less, we have the northernmost populations in the world. These are the northernmost Phrenosomas in the world, and there's one of them there. My rattlesnake field crew found these. Well, we weren't the first ones to find this population, but we rediscovered it after about 20 years. And these guys are basically in the same position as the Inuit up in the Arctic. They're living right at the northern edge of the range. Don't go any further north. We have some trouble in trying to decide just why they're restricted. I've done a lot of thinking about distribution in Alberta, why they only found in some spots and not in others. Because that part of the province is absolutely full of places that look like they'd be great horned lizard habitat, but nobody's ever seen one before, and we don't know why. Anyway, I've been working on them since, well, geez, when was that? Late disco age. Okay, this is back in '79, I think. And then, well, if you've worked on horned lizards in the field, you'll know what tractable little things they are. There's me taking data on one. I don't have to secure it. It just sits in my hand. It's marvelous. You can sit there and take notes. And that's from when I was working on my master's. Then there's later in the 90s doing radio telemetry. And there's some work we've done in 2000s, early teens, I think. There's Magdalene, who's actually here today. We're helping her in our project to look at population genetics of the species in Alberta and phylogeography. But I won't say anything more about that. So a lot of long-term, well, not long-term, but yeah, fairly long-term work. I've been working in the ecology for a long time. Now I'm going to say a little bit about growth, and then that'll lead into something Nick has to say. When I was doing my master's, I did mark recapture work and had a really good recapture rate. It was about 25% of something like 300 animals. Now that's the result of a lot of field work. I basically lived in the field for months on end, and spent all my time hunting lizards in spots that I knew where I could find them, and looked at 3 sites in particular that seemed to have good numbers. And one of the things we wanted to look at was how you get from here to here. There's an adult female, there's one of her neonates. And we had no real information on anything to do with that. You know, how do they get big? How big did they get? And something else we were interested in was sexual size dimorphism. That's from Chin Cooley. I actually caught these 2 together, which is extremely rare, finding 2 lizards close enough to get one another, you catch them at the same time. There's a big female, but not unduly big. She's about 75 millimeters, maybe a little bit less. That is about the biggest male I ever caught. He's 50 millimeter snout band length. So there's really pronounced sexual size dimorphism in these populations. And this is more or less true of Phrynosoma everywhere, but not as accentuated as we see here. I was just looking at a thesis from, where was it? Autonomous University of Mexico City. Somebody looked at Orbicularia and looked at growth in those. And she found that there is a bit of sexual size dimorphism, but not all that much. Males get pretty much as big as females, but generally speaking, in Phrynosoma, females are the bigger sex. Well, why was that? Well, I'm not going to get into that in a lot of detail. It has to do with vivipary. Of course, these are viviparous species, give live birth, which probably has a lot to do with why they persist in Alberta. And males, well, we'll talk more about that when we get to home range, if I say anything about it. Anyway, we were able to come up with growth models. So there's how a male grows, and there's how a female grows, and the males bail out, basically. The growth trajectories are quite similar up until about 210 days after birth. That's not counting the winter. And then males taper off at around 50 millimeters, and females keep on going for about another year, and then gradually taper off around 70, although they get bigger. They get to 70, 75, 80 sometimes. So this is just an idealization. And we could actually project capture size and time on growth models for the population and get some sort of structure. Now, these are kind of off, because when I did this, we didn't know about actually how long they were active during the summer, but there's males. And you see they don't get all that big. And you know, you can tell from this, it's hard to sort out how old an animal is by how big it is. And for females, it's not much better. You can sort them into neonates, sexually immature, and then you get up to here, they could be living for 10, 15 years. You'd never know. We don't think they live that long. I think it's maybe over 5. Nick, I was going to say a few words about life in a cold climate. Do you want me to bail out here and let you get on with your next tranche, or shall I just finish this bit off?
Oh, go for it, Larry. I'm sure there won't be too much coverage here because yeah, I think it'll fit nicely. Go ahead.
Well, one of the reasons I started my master's was, what were these lizards doing here? Alberta and Saskatchewan are cold. You heard Nick and I complaining about the temperatures before the talk, maybe if you tuned in early. This particular individual here, this was just after an August snowstorm in southern Alberta. And you can see this is, well, one of the things they can do is take shelter, but they stay active through really wretched weather. It's really quite surprising. I didn't really catch on to this when I was doing my master's work, but something I did in the 90s was radio telemetry. And the reason I did this, well, Fish and Wildlife wanted me to find out where they overwintered because we had no idea. And actually almost all reptiles except mahognose snakes in Alberta overwinter below the frost line. All the snake species find dens that go deep and spend their time below the frost line. And the frost line here can be about 1 meter deep. So you've got to get down if you're going to avoid freezing conditions. And I thought that's what horned lizards did, but I could never catch them at it. And something that you notice when you're doing field work on them here is that around the beginning of September, they vanish. It's very hard to find one. And the assumption always was, well, they've all gone off to where they spend the winter and they're staying there and they're playing it safe because September weather here is pretty unreliable. You can get snowstorms and sub-zero temperatures. So they're playing it safe. So Fish and Wildlife suggested I radio track them to find out where they were going, which involved, again, a lot of time in the field. Finding lizards. There's the radio I use. There's a Canadian penny, which we don't use anymore, actually. And there's a reasonably sized sub-adult female with the radio beside her. And you can see I've coated it with grit and glued it on, actually, so it doesn't show up. I didn't want them being conspicuous because Nick will be telling you that avian predators are really a major enemy. So I didn't want to have these guys standing out. And there we are, suturing a radio onto the back of the lizard. It's anesthetized. It doesn't know what's going on right now. Always tricky. And I was restricted. The radios weigh about 1 gram. So I was restricted in how big a lizard or how small a lizard I could put them on. I could only put them, well, I set a cutoff at 10 grams. Anything smaller than that didn't get a radio, which made it very difficult to get any data on males because they don't get much bigger than 10 grams. So most of my data were on females. And there's a lizard in the field with a radio on her back. This is the kind of substrate Nick was talking about, bear paw shale. Very friable stuff. It's actually really good for fossil hunting. And there's my study site. And this is very much like the area Nick was talking about, Val Marie, but this is in southeastern Alberta. It's on the south edge of the Cypress Hills. It's about not quite a kilometer elevation. And we can see we've got all these draws down to this big coulee bottom. And this is all bear paw shale and some bentonite benches as well, which are very tricky things to circumnavigate. Anyway, I was able to get a lot of data on home ranges and a pattern to point out. There's a square meter and there's north. And you can see that there are areas that they use for activity for a while, and then they move off and set up shop in another area where the activity is quite restricted. And then they start moving long distances and coming back. And this here is a fall movement. So I was tracking this animal through late summer and early, well, most of the fall, actually, they stay up late. And finally, she wound up down here and messed around a little bit, made some back and forth excursions and settled on that and then disappeared. So I don't know where she spent the winter, but that was telling us something, that they shift habitat early in the fall and, well, spend their winter down where they wind up. So here's another long-term study or long-term track. Again, localized activity, small areas, there's a square meter, more here. And this one wound up here. Well, there's another small area activity. This is one of our overwinterers. I'll say more about that later. Here's a smaller snapshot. And this is something else gravid females do. She was making her way across a grassy area and wound up on the edge of a draw. And in the last month of her gravidity, this is the kind of area she moved around in. Very small. There's a square meter. So adult females, gravid adult females, find what look like safe areas. They're not very mobile then. And they stay in these small areas until they give birth. Here's another one that was spending the last month of her gravidity within a really small area, a square meter. Once she gave birth, off she went. She lost her radio at the same time, but I know she went quite some distance before disappearing. Here's another one I tracked through the fall, and this is a more ambiguous pattern. There's a square meter, and that's where she wound up to spend the winter. This was one I was able to actually track. And this is, a bit more about home ranges. Look at the size of them. I mean, 4,000 square meters, that's pretty big. This is number of days I observed them, and this is home range area in square meters. And there's quite a bit of variance in there. The dark ones are males, and as you can see, I have very few of those. And we have these over here, which look like really small areas for a lot of observation, but these are in 2 subsequent years. And it looks to me like these animals were active in a certain area. I lost them in one season. And then I was able to catch them again the next year, and they were active in the same area. And given the patterns that we looked at before, it seems to me that the horned lizards spent their whole active season moving around from place to place within a large area, a large home range, and restricting activity to small patches of that and shifting them as the season progresses. Now, it could be they're doing this because they were alarmed by predators, something like a crow or a sparrowhawk or something like that. No data there, but it's an interesting pattern. And it looks to me like the total home range is actually pretty big. That's just lizard's size. And you can see there's not much of a pattern there at all. Okay, but to some degree that's dependent upon my data. Anyway, what did I find with regard to home range, or sorry, overwintering? Well, this is on my study site, and this is where 2 lizards spent the winter, under here. Okay, so they were in a draw. This is the top. This is prairie. Okay, so back from here on is grassland. But they spent I tracked them to the upper slopes of this little draw. Came back in late March, and this is late March, and the draw was full of snow. And something else that was of interest was that there were lizards active on the surface when I came back here in late March, early April. They were males, not females, but they were active. And something I should have stressed too was that I was finding like these lizards here that I tracked. It was until late October. It was really cold. I found lizards active on the surface on days that I would never have thought to find them. I found one running around when it was about 2 degrees above zero. It was a nice sunny day, but the lizard was active. You would never think that a lizard would be active at temperatures like that. I excavated the den in late October just to see where they were. There's 2 of them in there in this little burrow, and covered it back over. I wasn't very happy about this, but I wanted to make sure that they were actually there and not just their radios. They hadn't been killed by a grasshopper mouse and dragged in there or something like that. But there they were, tucked up against each other. And this is what I found when I came back in early March. They were under about 7 centimeters of earth. There's one of them. Actually, this one didn't make it. She's dead. But the other one did. So I've demonstrated they can make it through a winter under about 20 centimeters of snow, maybe more, and 7 centimeters of earth. So it looks like they don't have to go below the frost line. Now, this is what Nick is going to look at. So I'm not going to say anything more about it, and we'll pass it over to Nick, and we'll come back to that later if you want to. Okay, Nick, all yours. Tell them about your overwintering stuff. I've taken far too long. I'm sorry.
No, that was great. That sets the story so beautifully, because it was this work when I first read this and first talked to you about it that really set me off, because I have been watching these lizards as a as a non-academic exercise to keep my blood pressure low. I've been watching lizards for a long time in a lot of different places. But it was these lizards and their patterns that Larry's just beautifully described that really got me interested in a problem that I couldn't understand, which is every other northern reptile I can think of gets below the frost, generally. There are some that utilize moisture and things in different ways to take advantage of a raised frost line so they don't have to go as deep. But 7 centimeters is absurdly shallow. this is I've done overwintering experiments with snakes in Manitoba, and we had snakes going all the way to the water line to get out of the frost because the frost was 1.5 meters down. And this area has less moisture, which means there's going to be more fluctuation. And so I think the critical element of Larry's picture there was that there was always snow in the pictures. Snow seems to be, and Larry has mentioned this in a number of reports and papers, snow and they seem to overwinter in these areas with snow. And that brings us to the subnevian, which is that layer of snow where snow meets ground. And this is a critically important microhabitat for a lot of species. You can see here how relatively stable underneath the snow temperatures are compared to the surface or the air temperature. And this microhabitat is critical for lots of species. It maintains relatively stable temperatures, and they're usually relatively close to freezing. And that's because of the insulation provided by the snow, but also because heat is being released from the soil. And so it provides this protection for species that are active in the winter, but it also provides stability for species that enter states of dormancy, like brumation, like these lizards do. Unfortunately, this habitat feature is in decline, notably in the Great Plains. Oops, I went too far. So you can see here in this diagram from Pauley 2013, this is snowfall in 1971, and this is snow retention in 1971, and this is snowfall in 2008. The difference, and it was a relatively linear decrease, was a loss of 6 million kilometers squared of snow cover in the Great Plains primarily. And so how does this affect ectotherms in these extreme environments that can range more than 80 degrees Celsius in a single year? And so how does that affect species like Phrynosoma hernandezi? So I just want to sort of preface that 80-kilometer variation. This is the landscape. This is about 6.5 kilometers from my house here. We're in a fairly arid climate. It's very dry, which means that temperatures fluctuate because there's no moisture to stabilize temperatures. So to give you an idea of what these lizards are choosing from, if they are in fact choosing snow, this is October 25th on the top, and this is November 1st on the bottom of the same year last year. And there's actually a female buried right here under this lip of juniper and grass. And to give you an idea of the temperature swings in this area, the range for 2017, which is the last one I could get really nice data from, was 38.5 was our highest temperature, and minus 44.2 was our lowest temperature without wind chill. And so these are massive temperature changes. And we, as Larry was mentioning, we get August snowstorms. I have yet to have a solid garden in the last 15 years because we always get frost or snowstorm at some point and it ruins all the tomatoes. The other element here, beyond just fluctuation and over a season or over a short period of time like August, is we have a massive fluctuation in the amount of moisture we get. And most people, because we are primarily in a ranching area, most people consider that those critical spring rains that are going to get the grass really growing so that cattle can eat them. But drought is a wintertime thing too. And so, for example, last year we had only really this one big snow in October, and then it just dried out and we had no snow after that, basically. But most of our snow is not like fallen snow where it lies. Most of our snow is windblown snow. And so that microtopography that Larry was talking about becomes critically important because we're talking about the retention of snow, not so much where the snow falls, but where it blows and gets caught into. And then we have to consider how our wind patterns are. And our dominant wind is here from the north-northwest. What has such extreme sun here that most of our snow doesn't, well, most of our snow melts, but a good portion of the snow, especially in southern aspects, just sublimates. So it turns from ice into water vapor and disappears, with providing basically no benefit to the soil. And so when you're considering where you would want to choose, if you were choosing your overwintering site based on snow, it becomes a very uneven distribution of snow. And so we should see really pools of overwintering individuals, specifically in the coulees and specifically in the south and southeastern portions, where we get the shorter morning sun than in the southwest or the west. And that's generally what we're seeing. Where I see the majority of lizards in the late fall and in the early spring are primarily southeastern facing coulees and draws that have often quite a few lizards in one spot. I read Larry's report there that they were overwintering in the same burrow. But they do prepare some of their own burrows, and they also use pre-existing mammal burrows, as Larry pointed out. These areas are often in surprisingly steep coulees, and they, as Larry has already pointed out, they're often very, very shallow underground. I've not dug any up. I don't have the permits to do that. But where I do watch lizards, I've been able to follow a couple of females back to their burrows just through regular visitation of females. So what I wanted to address was a couple things. The first, to determine if coulees and areas that retain snow do provide a stable thermal environment, and to determine if snow retention is reflective of their overwintering survival. So I'm working on a small project for that, which the Conservation Society has very generously funded. This is one of the females I tracked back to her overwintering site, and she was actively excavating it for several days, and was very, very tolerant with me, although I kept a really good distance. I always stayed about 30, 40 feet from her. But yeah, this is a burrow. I don't know how far it went back, but as soon as it snowed and melted, this burrow, you wouldn't be able to tell there's a burrow underneath. It just disappeared. And so here's what, here's sort of an operating hypothesis as to how this might work. Presumably, this snow is providing stability. If a lizard is buried in the bottom of a coulee, it has all this warm-ish soil to provide it with extra stability. And if you top over snow on top of that, that lizard is functionally deeper than a lizard that has buried itself on a flat surface in the same habitat, even with a little bit of snow. Additionally, the snow does fill in, and so might provide additional stability. The issue here is, does it provide enough stability to avoid freezing altogether, or are these animals freeze tolerant? And so to try and understand some of these questions and to address those aims, I've used paired thermal loggers, some on flatland, some in coulees, and then I've got some on the surface as well, to see if there is any difference in the temperature that these areas measure. And then I'm going out once a week and I'm measuring snow to look at the depth and retention of the snow. So this is just an example of what a site looks like in the fall. And then this is with the same site in the middle of the winter. So you can see that there's not a lot of actual snow, but it is very, very localized in these coulees. So it does make sense, if this is providing some benefit, that these lizards would gravitate to these relatively obvious topographical features. And then to address that second aim, I'm doing some basic measures of population estimates. They're pretty simple because this is a relatively fine scale area, and I do know where a lot of the regular females tend to show up. They're very philopatric. As Larry said, if you show up at the same time in the same place at the same time of year, you'll often find the same female relatively close to where you found her the previous year, despite the fact that they do just disappear sometimes in the year. But for example, I watched one female for 5 years, and I never saw her in the early spring and I never saw her in the fall, but basically from late May until August, she was in the same area that was a little bit bigger than a pool table. And she spent every single day there for years. I just saw her every single week with my kids on our little walks. I've also been granted permission to do some mark recapture. I worked with Grasslands National Park this year. So under their permitting, I did some mark recapture using just a regular Lincoln-Peterson estimate. And so I marked lizards and then came back and tried to collect them with a different group of volunteers in an effort to figure out how many lizards are in this little area. I also collected a bunch of topographic data using drone photography, and I'm still waiting on some of that, but it looks really good so far. So preliminary data, the issue is last year we had an absolutely terrible year. We were in the middle of drought, and last year I did observe some females prepping burrows, and which is when I wrote this little study up. This year, I found 0 lizards prepping burrows because the overall number of lizards I observed was far lower than the normal number I would observe most years in the last 10 years. So I'm going to have to revise my methods ever so slightly. And after a nice chat with Larry, who's kind enough to give me some advice, I've been working on minimizing the requirement for seeing lizards and testing exactly where lizards are this year. And instead I've focused on generating a general estimate of what the different habitats available to them are generally according to cardinal directions and position on the slope. So using the number of loggers that I have available to me, just trying to get the best estimate I possibly can for the available habitat. This year, there's also not much snow. So my snow measuring didn't start until last week because we just didn't have any. But we have some fantastic snow now. We had a big snow last week and a good snow this week. So I've been out measuring snow every week and at the point of the data loggers, and I'm going to get the amount of snow that's over top of those data loggers to get an estimate of how much insulation that snow actually provides and how much snow those coulees actually provide. I just want to point out this is a little preliminary model of some of the data that we've collected with the drone, and we have a 2.35 centimeter resolution in 3 dimensions. So we'll be able to actually measure basically to the inch how much snow we're getting. So we'll be able to know in these gaps. So it's a pretty cool little project. And with that, I'm going to let Larry go back and we'll do trophic interactions. And if we go a little too long, Larry, I can always cut trophic interactions real quick.
Idiot, I keep forgetting this. If the moderator can tell us just when she wants us to shut up.
Oh, this is fascinating. I'm listening to every word, so you can keep going.
Okay, Nick, why don't you? I've got a couple of slides on diet, but
sure.
It's not the same as yours. Why don't you go ahead and show yours, and then I can show mine.
Sure. Yeah. Well, I won't do too much on diet. Larry's going to speak to the specifics of diet. I did want to point out that horned lizards do eat endangered species. Here's a 9-spotted lady beetle that we found in a horned lizard scat. And I also wanted to point out that the females especially seem to really like big grasshoppers. But they do play an important role as a trophic link in these food webs. But I wanted to focus on some sort of cool case studies of things that are feeding on them, because I've been very lucky in all my wanderings to have come across some really interesting examples of predation, which, given the size of the lizards and the things that usually eat them, it's not a common thing to come across a partially eaten lizard. So just a warning for those of you that don't like semi-gruesome pictures, I have some semi-gruesome pictures coming up. So the first one I want to talk about is a mammal, and I'll go through these pretty quick so we don't run too long tonight. But I wanted to point out this interesting damage on this adult gravid female that we found back in 2018. You can see the damage on the back of the head here. Horns chewed off, and the back of the skull is chewed on, and then the eye socket was right down to the nares. According, Larry and I had a nice chat with Wade Sherbrooke, and we're all in agreement that this is probably a northern grasshopper mouse, which we do see here. And 2018 actually happened to be a pretty good year for them anecdotally. And so this was a female that seems to have somehow survived the attack from these monstrous brain-eating mice that roam this prairie, terrifying all of us, despite the fact that they are quite cute by mouse standards. Although they walk like little weightlifters, they are real shoulder strut to them. But this female actually lived through that attack. By the time I saw her, she was all healed, and she was actually surrounded by neonates. There was 5 neonates around this female. We found her just after she'd given birth, so she had healed up and continued to reproduce. So this was a really nice thing to see, not just because it's an interesting observation, but also because she's still reproducing. And here is a scan that Larry provided of a similar individual from Alberta that was presumably attacked by a northern grasshopper mouse. And you can see the damage to the, especially the jugal bone is completely chewed through here. So they've chewed right down to the jaw. Probably, I don't know, Larry, this animal was not alive, I presume.
Oh, that's a museum specimen, but it had healed. Okay. It was like yours. It had healed, Nick. Mind you, it seemed to me that this eye, the right eye was gone.
Yeah, it would have to be enucleated. There's nothing to hold it in at that point. But yeah, it's so. I mean, this is the type of animal we're dealing with. These are incredibly tough lizards, not just because of the temperatures, but just the physical toughness of these lizards and their ability to survive some pretty heinous injuries. Unfortunately, the rest of these were not survivors. This was an interesting one. I had a number of questions because this was reported to me by Laura Gardner, who is a fantastic herpetologist that's based here in Val-Marie. And she found this on her walk in town at the base of a telephone pole. And this is 5 kilometers from any known population, or more than 5 kilometers. And it was missing a head, its shoulder, and 1 arm. And it took us a little while to figure out what was going on until a pair of merlins set up shop right beside the telephone pole in a spruce. And then it all kind of came together because we found some other dead animals at the base of the pole. So we're thinking that the merlin didn't necessarily mean to drop this, but this is probably a falcon that actually took a horned lizard, which is pretty cool. So you don't usually think falcons taking, such well camouflaged, cryptic, ground-dwelling animals. This next one is a slightly more interesting one just because of the connotation it has. I've heard of 3 examples from grasslands of this type of predation. I've seen some pictures. This is the only one I found like this, and I found this again in 2018. It had a very, very distinct modus operandi, which was really limited punctures and dislocated hip. And then the only thing that was missing, so these were all gravid females. The only thing that was missing was the liver and heart. And this is classic corvid behavior. So you can tell because the hip has been dislocated from one of the centrifugal slams that Wade Sherbrooke always talks about when talking about bird predation on horned lizards. And then the really, really pickiness about just taking certain items of the viscera while leaving the rest of it is classic corvid. I don't know whether this was crows, ravens, or magpies. I would argue that it's probably ravens because they're the ones we see most commonly on these open prairies. And I just wanted to direct your attention to the general increase of raven populations in the prairies since the 1970s. So although ravens were probably quite common when bison roamed in huge numbers, they basically disappeared in the early 1900s. And in the 1970s, as humans began to subsidize them, they moved back into the prairies to the point where they've gone through these massive, massive numbers explosions. And we see them most of the time now when we're out looking for lizards, which does pose a real threat because they're incredibly smart and they're quite capable of following researchers and taking advantage of where we found a relatively cryptic potential prey item for them. And actually, I saw Patrick was on here, so he could speak to ravens and their wiliness related to turtles. And the last one I'm going to talk about is loggerhead shrikes. Now, we've seen dozens of loggerhead shrike predations, which is interesting because they hadn't been observed before 2012, I think. And most of them we see are on fences, but we have seen some natural impalements on buffalo berry. Some interesting patterns that we've observed in the sort of 45 or so observations is we've never seen an adult female, and none of these lizards have received a cervical separation, which is typical of shrike predation, i.e. they typically grab behind the neck and the high cervical vertebrae, and they put the tip of their beak in there, and they just snip the spinal cord, and the animal is functionally helpless at that point. Now, horn lizards are not, as Larry pointed out when he was just having one in his hand, they're kind of helpless in a sense once you've captured them already. But interestingly, almost all of these lizards, you can tell by the bruising here, almost all of these lizards died from impalement. They didn't die from being killed by the birds firsthand. The other thing that was really interesting about this pattern is, despite the fact it seemed to be incredibly rare before, there are some sites now where we can almost guarantee we're going to find lizards pinned to the fence or pinned to a bush. But they're very clustered. I've searched 1,000,001 little larders for shrikes, and I found all sorts of frogs and things like that, but very seldom did I come across lizards, except for in a few families' larders. And so I do wonder if there's some family specialization and some learning patterns here that would allow for some families to really succeed in these areas with high lizards. But I don't have any data to suggest that. So this is a bit of speculation on my part. Larry, if you don't mind, I'm just going to do some acknowledgements here and you can finish us off. Is that okay with you?
Yeah, by all means.
I have some specific acknowledgements of people that have really helped me in this recent work, especially. The Horned Lizard Conservation Society has helped a great deal. They provided me with the funds to get the initial data loggers that I got, and that funding was provided by Laurie Peppenbrink, and so I'm very grateful for them. One of my undergraduate thesis supervisor back from my undergrad also gave me some eye buttons from her collection, as well as my PhD supervisor. And Adam Sprott came in and provided the drone and the analysis from the drone for free. So I'm just completely indebted to a lot of people, as well as a fantastic group of field assistants, and Larry for his advice. So with that, I'm going to end my part, and I'll pass it back to Larry. He can talk about diet.
Okay, thank you, Nick. Boy, that was great. I mean, it's really nice to see somebody following up this overwintering stuff. It's been bothering me for decades. Anyway, I've got a lot. I'm not going to spend much time on this. I'm sure you've all got things to do. I've got a fair number of sort of not natural history, but ecology slides. And we'll look at a couple of them just to, where is it? Hang on. That's funny. Oh, here we are. Blast this thing. Okay, sorry. I'm screen sharing now, right? And you can all hear me? Okay, we finished up here. I was going to say a little bit about life in a cold climate, but I think I've already said it. This is just temperature distributions. That's cloacal temperature distribution of animals that were caught. Okay, so it's free-ranging animals. You can see that gets down below 20 and up to almost 40. Over a wide range of ambient temperatures. That's substrate temperature and that's air temperature at 1 meter from the ground. So they're active when it's cold and uncomfortable, even for us. And if we look at the relationship between body temperature and substrate temperature, well, that's the isothermal line, and they're obviously thermoregulated quite well. They're really very good at this, at maintaining a high temperature, even when the environment is quite unpromising. And this is for air temperature again. And of course, they're even better thermoregulators against air. They're almost always above the air temperature. It gets up to, well, we've got air temperatures of 35 degrees plus. It does get quite hot in southern Alberta too. I wanted to say a little bit about reproduction. They're viviparous. I guess you all know that. This is something I found in the back room of my field headquarters when I came home one day. I'd sequestered a few gravid females and found that they all gave birth at the same time, practically around noon, and on the same day. There seems to be real synchrony in reproduction here. So there's one of the neonates with its amniotic membrane coming out, and there's a typical clutch. Big female, and she had these on my desk at the university here. Again, when I was off for lunch, noon again. It was a different year, so it seems to be a consistent thing. And she's got what, 5, 10 offspring, something like that. Clutch size varies. We managed to get some data on this. So there's neonate size, and they range from, well, half a gram up to a little bit over a gram. And there's relative clutch mass, and you can see that some small females put a lot of effort into reproducing, and some small females don't. There seems to be a general trend that it goes down. The bigger they get, the less reproductive effort they exert in terms of relative clutch mass. And I think that's to do with, has a lot to do with why females get so big. It means that there's less of an effort really to carry all those neonates around. These two here, we're probably breeding for the first time. These ones probably the second or third time. A little bit on diet. We did gut flushing, or I did gut flushing, which is really pretty awful, but at least the lizard gets to run away afterwards. And did it for about 100 animals. And of course, horned lizards are held to be ant specialists. And yeah, you look at diet item, percent diet by item count, and most of what they're eating is ants, individual items. But they eat a lot of beetles and have a fair bit of taxonomic diversity just by count in their diet. But if you look at weight, and this is maybe a little iffy, I did dry weights of all the gut samples I had, and ants are down to about a third of it. And a large fraction is orthopterans, as Nick showed you. They do like getting a big grasshopper, and it's quite surprising how small the lizard might be to bring down a grasshopper. Again, I was limited in what I could gut flush. I didn't want to do it to any little animals. It's a pretty horrible process as it is, but I didn't want to, rupture anybody's gut lining or anything like that. So these are bigger animals. A lot of beetles too. But even so, you would get an animal of about maybe 12 grams, still choking down a huge grasshopper. So a lot of dietary diversity. Now, what else did I have to say about? Oh yes, the bigger you are, the bigger the prey items you take. And actually, we found that there was some reason to think that they were divvying up the dietary niche to some degree by prey size. Big females take a range of prey size that overlaps the male range. Males and subadult females, but males and subadult females don't take such big items as fully grown females. Partitioning of the dietary niche, well, it's a little iffy. It's doubtful that it was natural selection to do this, but being of different sizes between males and females does mean that they aren't competing quite as much. Okay, I'm going to spare you this. This is some research I've been doing recently. It's on head shape. Can I take a minute or two just to go through this, because it's germane to what Nick was talking about with defense.
Sure, go ahead. I know we're past our hour, but those who want to stay are welcome to stay. And if people have to go, then they can. But we are recording this, so I would love to hear about it. Okay, I'll try to keep this brief. Something I've been looking at in the last few years is the variety of head shapes in horned lizards. Now, here's a sort of a gallery of various horned lizards. These are the short horned ones, like ours.